Hello and welcome to this latest DPA video interview. Today I'm with Andy Turtle, WAGO UK and Ireland's interface expert for power supplies. We'll be discussing the subject of how the choice of DC power supply control system can make a significant contribution to overall plant efficiency and uptime. So Andy, the selection and specification of a DC power supply is often carried out by the OEM, system integrator or panel builder. How might this affect the performance of the end user's operation?
Well, mate, thanks, Paige. Power supplies vary considerably from a standard low-cost switch mode power supply, SMPS, to a field-connected, highly efficient product. Power supply is at the heart of the control system and is therefore critical to the operation of the machine it is part of. So, for example, if the power supply fails or is overloaded and trips out, a stoppage of the process could occur. And consider an essential utility or manufacturing process that is offline and the resultant cost both in terms of lost production or penalties due to compromised service level.
Okay, that's interesting. So, given how important the power supply is, what capabilities should the control system designers be looking for in order to offer their customer the best solution?
Well, there are three ways in which the power supply can really enhance the end user's operational efficiency. First, the ability to continuously monitor the DC control system to look for telltale signs of potential problems developing. Knowledge of such an issue before it creates a complete stoppage is a really powerful benefit which can enable a batch process to be completed or a continuous process running on until the next planned maintenance window. Secondly, the reliability of the power supply itself. Being an electronic component, its likelihood of failure is based on the projected mean time before failure, the MTBF. So it makes sense to choose a power supply with a long life expectancy. WAGO's Pro 2, for example, has a 1 million hours MTBF and a 15-year design life thanks to the use of high quality, oversized electronic components. The tolerance of the power supply to low or high temperatures, shock, vibration and tolerance to overvoltage transients will also contribute to overall reliability. Lastly, the power conversion efficiency directly impacts on two things: the amount of heat that must be dissipated from the control panel and the amount of power that the end user will be billed for. For example, WAGO's largest 40 amp Pro 2 has a class-leading 96.3% efficiency. Compared to a typical power supply of around 91%, a considerable saving of around 37 watts is achieved. One of our customers is using 14 of these in one control panel, and that represents a potential saving of over half a kilowatt, which in turn means a considerable reduction in panel ventilation and cooling requirements, directly benefiting the panel builder. For the end user, of course, this is a considerable saving in energy costs and considerable contribution to carbon reduction ambitions.
Picking up on what you said about continuous monitoring of the power supply, what sort of information is available?
We'll take WAGO's Pro 2, for example. Real-time monitoring of many key metrics are possible, including the instantaneous current, energy consumed, and an extensive array of warnings such as over, under voltage, current overload, current limit exceeded, and device high temperature.
I can see that for the end user, having access to such information is a real benefit for predicting problems and planning maintenance. Does the communication capability provide any benefits to the OEMs or system integrators?
Yeah, absolutely. We're all becoming aware of what Industry 4 represents in terms of connectivity and the access to devices at the granular level, as defined by the notion of the Internet of Things. Consider how advantageous it could be for the OEM or integrator to be able to log into the power supply from a remote location and make an adjustment to a setting or check for any alarm conditions. WAGO's Pro 2 even has onboard real-time logging that can be exported for detailed analysis. This sort of capability could save the OEM or integrator considerable time and money during commissioning or maintenance. It could even represent the difference between a site visit or not, which in today's world is extremely advantageous. Fundamentally, having access to the power supply enables quick, informed decisions regarding the overall health of the DC system. And as they say, Paige, knowledge is power.
Brilliant. Thank you very much, Andy. And to find out more about the solutions offered by WAGO, please visit their website. All the details will be shared on screen shortly. Thank you very much.
Many thanks, Paige.